In this video, I will demonstrate how to apply basic digital signal processing filters on an actual audio source. All of these will be done in Python. First off, you will have to import a couple libraries in Python. We will be primarily using the NumPy library for array management, matplotlib for displaying our final graphs, and a couple functions from SciPy. In this case, we'll be using the wavefile functions to read in a digital wavefile audio clip. Start off by reading in the wavefile using wavefile.read. This will give you two outputs, the frequency and the raw data. We will have to convert this raw data into NumPy array form, and then we can call this our time domain data. Next, we have to convert our time domain data into frequency domain data. This second domain allows us to apply very simple filtering techniques on specific audio frequencies in the input data that we have. To do this, first convert our data using mp.fft.fft, so that's the fast Fourier transform library. And we also have to extract the frequency range that corresponds to each of the indices of the data that we have now converted. Otherwise, the data that we have converted will have an arbitrary frequency range once we start actually manipulating it. But by using the numpy.fft.fft frequency, we can generate a specific frequency value range for every single value in our data. Before we actually start applying any filtering into our audio source in frequency domain, we should first check that our audio can be brought back into time domain, and then we should save and or play it. In this case, we can use numpy.fft.ifft, or the inverse of fast Fourier transform, to bring the frequency domain audio back into time domain. And using the same wavefile library, we can now write out the data that we have into a new audio file. Do note, we have to include the frequency of the data in the audio file so it can be actually played. The data that we get back from fast Fourier transform is in complex form, so we just need to extract the real domain data. And finally, we need to convert the data into int32 or anything which is compatible with the audio player of your machine. Additionally, I will also plot all of the data. So I will plot the time domain data that we read from the file, so we can get a glimpse of how the time domain data looks like in raw format. And I will also plot the frequency domain data that we have generated using fast Fourier transform. And to note that the time domain only has time in its x-axis, while the frequency domain no longer has time, it has frequency in the x-axis. So this is where we need the frequency range to plot the specific frequency ranges. Now you can see that our frequency data here is actually mirrored in two directions. In order to fix this, especially once we start creating our filters, we just need to apply the absolute for the frequency range. And we can also apply logarithmic scale for the x range for frequency, making the data much more readable.